right, here is one more example on related rates. Please read the question, take a moment to draw a picture, to write down the goal as well as whatever information is given as a derivative. And only after you've done that, please come back and take a look at the solution that we have here. So if you would please pause the video after you read the question, give it your best shot, and then come back and watch the rest of this recording, please. All right, so hopefully you have done that. You have given a try. And let me start with the picture. So we have a player running from the second base to the third base. We call the distance from the player to the third base as distance x. We have marked the angle theta. And one side of the baseball diamond is 90 feet. That's also marked on our picture. So the question is to find the rate of change of the angle, d theta dt, at the moment when the runner is 30 feet from the third base. In other words, when x equals 30. And the given information is that the runner is going at a rate of 24 feet per second, and because the distance x is getting smaller, that distance, the rate of change of that distance is negative 24 feet per second. And how about an equation that relates all the variables? We have a triangle. We want to include theta and x in our equation, and we also know one side of this triangle is 90. So if you look at the picture, which trig function would be appropriate here? It looks like we know the opposite side of theta, or we have some information about that. That's the side x. And we also have some information about the adjacent side of theta. And a trig function that relates the opposite to the adjacent side is the tangent function. In this case, tangent of theta equals the opposite side, which is x, divided by the adjacent side, which is 90. Now, since the side of the baseball diamond does not change, the length of one side of the baseball diamond, that is a constant, and we can certainly put that into the equation as a constant. We don't need another letter to represent the side of our triangle. That's a fixed number of 90. All right, the next step always is to differentiate both sides with respect to the time variable. So if we do that, differentiate both sides with respect to the time variable, we get the following. Secant square of theta times d theta dt equals, and on the right hand side we can write it as 1 over 90 times x. So the derivative will be 1 over 90 times dx dt. And we know what dx dt is, so let's go ahead and fill that in. Dx dt was negative 24 feet per second. We are trying to find d theta dt, so I will leave that in the equation. And now we need to know what secant square theta is at that moment in question. So at that moment, the runner is 30 feet from the third base, so the side is 30. We have a right angle, and this side is 90. And we're trying to find the secant of this angle theta. So we will need to know the length of the hypotenuse, which will be from the Pythagorean theorem, the square root of 30 squared plus 90 squared. Again, you could set up the long equation, 30 squared plus 90 squared equals to c squared, and go ahead and get what c is from there, and you should get the following. All right, so now secant theta from this triangle is hypotenuse over adjacent, which is this. But remember that we need secant square of theta. So secant square of theta, squaring the right hand side, we will get, on the top we'll lose the radical, right? On the bottom, when you square it, you get 90 squared. Of course, you could have gotten a decimal answer for secant theta, and then you could have squared that quantity. But for this question, I'll just leave it like that and simplify it at the end. So secant square theta is 30 square plus 90 square divided by 90 square. And solving for d theta dt, basically multiply both sides by the reciprocal of this fraction. So that will appear on the other side as 90 square over 30 square plus 90 square. And we already have on the right hand side 1 over 90 times negative 24. And one of these 90s can be cancelled. So what we have is 90 times negative 24 divided by 30 square plus 90 square. If you're going to do this on the calculator, make sure you include the bottom in a set of parentheses. And now let's see what we're getting when we do that ratio on the calculator. Alright, the answer turns out to be negative 0.24. And remember that we found the rate of change of an angle with respect to time. And anytime we're doing calculations that involve calculus and trig functions, when you solve for d theta dt, automatically it will appear in the units for the angle will always be radians per whatever unit of time was. In this case, I believe it was in seconds. So d theta dt will be in terms of radians per seconds. And once again, the negative indicates that that angle is shrinking as time goes by. And if we look at the picture, that makes perfect sense, right? As the runner is going towards the third base, the angle is decreasing.